Good morning. I'm V.Manjibhashini, Department of Mathematics. I'm going to share some points about numerical methods. First, we will see bijection method. What is meant by bijection method? The bijection method is based on intermediate value theorem, which states that if f of x is a continuous function on the interval a comma b, that interval should be a closed interval. That means both the endpoints should include in that interval. And f of a and f of b have opposite signs, that is f of a into f of b less than 0, then there is at least one root of the equation f of x in the interval a comma b. Now we will see the assumption of this bijection method. F of x is a continuous function on the interval a comma b, and f of a into f of b is less than 0. That is, the function values at a and b have opposite signs. Next we will see the steps how to proceed this bijection method. Find the middle point c is equal to a plus b by 2. A is nothing but initial value of the interval, b is nothing but the end point of the interval. If f of c is equal to 0, then c is the root of the equation. If f of c is not equal to 0, then we can come to the point if f of a into f of c is less than 0, the root lies between a and c. So, we recur with the interval ac. Hence, if f of b into f of c less than 0, the root lies between b and c. So, we recur with the interval c comma b. If neither of these conditions hold, then the function does not satisfy the assumption of the bijection method. Since the root may be floating point number, we repeat the above steps until the difference between a and b is less than or equal to this very small value. So, now we are going to see how to find the root of the polynomial using bijection method. We use the bijection method to find the root of the polynomial f of x is equal to x cube minus x minus 2. The initial interval selection, choose a and b as 1 and 2. Evaluate the function f of 1 is equal to minus 2 and f of 2 is equal to 4. Since f of 1 and f of 2 have opposite signs, there is a root between 1 and 2. Step 2. The first iteration, calculate the midpoint C2. C1 is equal to 1 plus 2 by 2. That value is 1.5. Evaluate the function at C1 and f of 1.5 is equal to minus 0.125. Since f of 1.5 is negative, update the interval to 1.5 to 2. Repeat this process until the interval becomes sufficiently small, converging on the root. Here I have shown the geometrical representation of the bijection method. So the bigger red dot is the root of the function. This is the way we have to find the bijection method, the root of the polynomial. So here I have discussed another problem. Determine the root of the given equation x square minus 3 is equal to 0 for x belongs to 1.2 to x. Given x square minus 3 is equal to 0, let f of x is equal to x square minus 3. Now we find the value of f of x at a is equal to 1 and b is equal to 1, and f of 1 is equal to 1 square minus 3 is equal to 1 minus 3 equal to minus 2, which is less than 0. F of 2 is equal to 2 square minus 3 is equal to 4 minus 3, which is equal to 1, which is greater than 0. Here the sign changed now. The given function is continuous, and since f of 1 minus f into f of 2 is less than 0, then the root lies between the interval 1, 2. Let t be the midpoint of the interval. T is equal to 1 plus 2 by 2 is equal to 3 by 2, which is equal to 1.5. Now we find the value of the function at t is equal to 1.5. F of 1.5 is equal to 1.5 into 2 minus 3. So if you simplify this, we get minus 0.75, which is less than 0. Since f of 1.5 is less than 0, We update a and t is equal to 1.5. If you continue this process as iteration, we can get the 7th iteration in its value as 1.7266 or 1.7344. Hence, the approximation solution of the problem is 1.7344. This is a way to find the solution of the problem of the given polynomial using bijection method. Thank you.